Thank you. Thank you. Again, I stress, please judge this material by the references. Check the references. Read them for yourself. So part B then is going to deal with the fact that fluoride is neurotoxic. And the evidence for this has been gathering weight since 1995, when Phyllis Mullinex did one of the first animal studies on animal behavior and fluoride. But the weight of evidence is overwhelming, and no fluoridating government has yet to address this weight of evidence. But the weight of evidence is that fluoride affects brain chemistry. Now, to get all the references that I'm going to refer to in this presentation, go to this website, fluoridealert.org/issues/health/brain. Now, once you've mastered that, you can switch the word brain for anything. You can put bone, you can put kidney, you can put teeth, and then you've got access to all the literature on those tissues as well. Oops, sorry. So the animal studies. There have been over an animal studies that have found that fluoride damages the brain. Findings include damage to the hippocampus, neuronal degeneration, inhibition of the enzyme cholinesterase, which is involved in neurotransmission, interference with nicotinic receptors, which are also involved in neurotransmission, decreased brain glucose utilization, and increase in oxidative stress. So there are lots and lots of animal studies. The first thing that comes up when you talk about this, oh, well, animal studies, they use very high doses, but which is typical. If you don't use very high doses, then you have to use a lot of animals, and that's expensive. So they tend to jack up the dose. But in the case of fluoride, some of the experiments have been done at very low doses. For example, the study by Varna in 1998, they only used 1 part per million of fluoride in the water, and they found the animals had kidney damage, brain damage, greater uptake of aluminium into the yeah?
Your slide says deceased. Right?
Yes, thank you, thank you. Yes, I shouldn't be judging my typing, spelling. Okay. Anyway, Varna, they found increased uptake of aluminium into the brain and beta amyloid deposits, and that was all done at 1 part per million. So dose is not the way you get out of this problem. Now, I think even more important is there have been 30 animal studies which have been designed to test to see how well an animal learns and remembers. And they put them in mazes. And in 30 of these 32 tests, they found less learning ability and memorizing ability. In Y mazes, T mazes, Morris water maze, novel object recognition test, open field test, and so on. Again, low doses. You have to, incidentally, dose a rat at least 5 times more with fluoride to get the same plasma levels, which is critical. So 5 parts per million is not a high dose for animal studies. Now, they've also done, in addition to the IQ studies, they've done studies with humans, young children. And one of the ones I think is very striking is this complex figure test, where they show this figure to young children, ask them to copy it, and then they take the figure away and ask them to recall it. It's a high-quality study. They controlled for many, many important variables. They found that 9 out of 10 children who were exposed to fluoride were less capable of drawing this picture accurately than children of their age, and similarly, 6 out of 10 were less able to remember the drawing out of 10. Now, the IQ studies. There have been, out of 50 studies, 43 have shown a fairly modest exposure to fluoride. That will become apparent in a moment, an association with lowered IQ. And these studies have been done in China, India, Mexico, and Iran. And just one recently done in New Zealand. 19 of these studies were done at levels lower than the EPA's safe reference dose. For those who say these are all at high concentration. One highly publicized study is the recent study from Broadbent. I'm not going to talk about that because Bill Hersey has studied this closely, and for that matter, Jane Beck has also. So I'm going to leave it to them to show you how unsatisfactory that IQ test is. Now here's the thing which really set the press alight and many of the opponents. It was a meta-analysis performed by a team from Harvard, which included Philippe Grandjean, who's one of the world's experts on mercury neurotoxicity. And they looked at 27 of these IQ studies, because the methodology was the same. They compared the IQ in children in a high fluoride village with a low fluoride village. In a few of the studies, the source of fluoride was coal burning. We'll exclude that. About 20 were done where the source of fluoride was in the water. And the study was published in Environmental Health Perspectives, which is one of the leading journals of this subject in the world. Now, the Harvard team acknowledged, as everybody does who's looked at their studies, some of them are very weak. They don't include all the confounding variables that you would like to hear about and not discussed in many cases. However, they also concluded that the results were remarkably consistent. Remarkably consistent. Remembering these studies were done in different countries, at different places in the country, by different research teams at different times. And yet, 26 out of the 27 found a lowering of IQ within the high fluoride village. And the lowering was substantial, 7 IQ points. If you had a shift of 7 IQ points in the Australian population, you would halve the number of geniuses in Australia and you'd double the number of mentally handicapped, easily. So promoters claim that the concentrations in the high fluoride villages were very high and irrelevant to artificial water fluoridation. They will often refer to 2 of the studies going up to 11 parts per million. Well, there are all the 20 studies which dealt with water. The average of the means was 3.52 parts per million, and yes, indeed, 2 of the studies go up to 11, but it was the high end of a range in both cases. But more importantly for us, many of these studies were done at low concentrations. Here are 5 of them that were done at concentrations lower than 3 parts per million. Now, I want to give you details on one of these IQ studies. It's close to my heart because I know Zhang. I was invited to go to the 2 villages where he did the study. The 2 villages seem to be the same in all variables except one, the level of fluoride in the water. The low fluoride village, 0.36 parts per million mean, and the high fluoride village, 2.5. And he controlled for lead exposure, iodine intake, very important, and in retrospect he controlled for arsenic and found actually higher arsenic levels in the low fluoride village. So if it was a variable that interfered, it would have gone in the wrong direction as far as claiming that that was a problem. Now, he found a drop of 5 to 10 IQ points across the whole age range, and the whole IQ curve was shifted over, and the significance of that will become apparent a little bit later. Now, what he did that no other researcher, or at least not many, have done, he subdivided the high fluoride village into 5 subgroups of increasing concentration. If you look at the Zenyoe is the low fluoride village, so we forget that. The Wamayo, you see the subgroups A, B, C, D, and E. The concentration of fluoride, the mean concentration, this is all well water, went from 0.75, 1.5, 2.5, 3.3 to 4.16. And now look at the IQ. The IQs, you don't see much change at 0.75, but you see a significant drop of at least 4, maybe 5 IQ points at 1.5, and then a further drop of another 3 IQ points, and so on. So that is just what you want in epidemiology. It looks like a dose-response curve, that as the fluoride concentration goes up, the mean IQ of these subgroups go down. It makes it much more powerful than just comparing a high fluoride village with a low fluoride village. And by doing internally to one village, you've knocked out the difference, any variables between the villages. Now, he did another thing. He looked at the mental retardation rate, the rate of children who had an IQ less than 80. Less than 80 to 70 is borderline IQ, borderline mentally handicapped. Less than 70 is outright mentally handicapped. And look how these numbers increase. So you go from 0.75 to 1.5, 10% of the kids are borderline or outright mentally handicapped. It goes up to 15%, 21%, down here, 37.5%. Again, plotting it as the fluoride concentration goes up, the percentage of kids in the mentally handicapped range goes up. That is very serious and significant. Now, the lowest level that you can find here, and by the way, promoters should not be focusing on the highest level that causes a problem, but the lowest level. That's what you do in toxicology. You look for the lowest level that causes harm, not justifying everything because you can find a high value. But in this one, the lowest level is 1.5 parts per million, leading to a lowered IQ. And if you subtract the standard deviation there of 0.27, then there were some children in this group who had a lowered IQ at 1.26 parts per million. That leaves no margin of safety to protect all children from lowered IQ, drinking water between 0.7 and 1.2. Just no margin of safety, and Bill will quantify what I've just said qualitatively. There's no margin of safety. There's very little margin of safety. Oh, I should add something. In these rural children in China, it's highly likely that they were breastfed, not bottle-fed. So that's one major source of fluoride that they have less of than our kids do. And secondly, they weren't using fluoridated toothpaste, which is another source. So if anything, these kids were getting less fluoride than children in Australia. But in addition to that, okay, I've been through that. In addition to that, there's no margin of safety because we use a safety factor of 10. When you get a toxicological study which shows harm, to protect a whole population, you divide by a safety factor of 10. You take the dose which causes harm, divide it by 10, and say that dose is probably safe for a large population. And this takes care of intraspecies variation, the variation to anything, but in this case, the sensitivity to a toxic substance varies by at least a factor of 10 in a large population. And Bill Hersey will be bringing that out. Here is Bill. Not only was Bill a senior scientist at the EPA, but his speciality at the EPA was risk assessment. And so you're getting it from the horse's mouth here, literally. Now, to put this into context, the US EPA is in the process of determining a new MCL. That's the maximum contaminant level goal. That's what the National Research Council recommended that they do in 2006. So they're already 9 years into this and they're late. We're still living under the old MCLG, which is 4 parts per million, and that's based upon the notion that the most sensitive endpoint to fluoride's toxicity is crippling skeletal fluorosis. They don't count anything before crippling skeletal fluorosis. Clearly outdated by all the stuff that we have just seen. Now, what the EPA is doing this time round is trying to use severe dental fluorosis as the most sensitive endpoint to do their risk assessment on. Now, they claim that if they protect children, all children, against severe dental fluorosis, then they will protect the bones and brains of everyone, every tissue. They protect every tissue, children and adults, just by protecting for severe dental fluorosis in children. Now, to demonstrate that severe dental fluorosis is a more sensitive endpoint than lowered IQ, they would have to show that all the children in the high fluoride village, in all 40+ studies that we have, where IQ was lowered. In other words, if severe dental fluorosis was the most sensitive endpoint, and more sensitive to lowered IQ, all of these kids would have had to have severe dental fluorosis. And sorry. into it. Sorry about that. I keep pushing the wrong button here. Yeah, I can't see the button which gives the... Oh, there it is, isn't it? There it is, there it is. Okay. Okay, we've done that. So we asked Zhang, who was at our conference in Washington in September, we asked him to look at all his data and see what happens to kids with different levels of dental fluorosis. So here is all the children that he studied, about 500, and this is no dental fluorosis, this is very mild, this is moderate, this is severe, and this is the IQ. Now look, you can see that IQ in his children are lowered when they've got very mild, moderate, and severe. So the EPA's rationale is out of the window if Zhang's data is valid. Now, Zhang is on the left, that's me, and then you have Chris Neurath, who's our Senior Science Director at the Fluoride Action Network, and there's Bill again. And this was taken on September the 8th when we went to the Water Division of the EPA. And we explained exactly what I've explained to you. They were surprised. They didn't know much about these IQ studies. Bill went through the risk assessment, or a version of it, that you're going to hear immediately after this. And to their credit, one in particular, one of the two people that we met, they're pretty senior, said that he would circulate Bill's risk assessment to all the members of the risk assessment team. And we haven't heard a dicky bird since. This was September the 8th. We're still waiting. But in other words, what we're looking at now is the nexus between politics and science. Is the EPA going to play the loyal servant and continue to support water fluoridation by choosing severe dental fluorosis and pretending there's no loss of IQ? Or are they going to be true scientists and do the right thing? And if they do the right thing, as you'll hear from Bill's risk assessment, fluoridation will be over. So we just need a few people in Washington, D.C. to be honest. But that's damn difficult. That is damn difficult to find them in Washington, D.C. Now, since then, Choi, who did that other study in 2000, the meta-analysis, have done another study. This is a preliminary study. The good news is that one of the people involved in that study is David Bellinger, who's one of the world's expert on lead neurotoxicity. So we've got grangene, mercury neurotoxicity, and now Bellinger involved. And what did they find? They found a relationship between dental fluorosis and a test that they administered. In this test, they asked the children they give the children a series of numbers, and they ask the children to repeat that series of numbers both forwards and backwards. And the results, if you look, I'm going to look at this. So this is where statistics, you have to be so careful with statistics. If these are the confidence intervals. This is the confidence interval, 95% confidence interval. And what statisticians will tell you that if these vertical bars overlap, then these are not statistically different here. But these are the performance with the kids who had normal or questionable dental fluorosis. These are the kids who had very mild or mild dental fluorosis. These are the kids who had moderate or severe. So at the 95% level, you've got what looks like a trend, but for any 2 points, they're not statistically significant. However, with the vagaries of statistics, if we'd chosen a 90% confidence interval, you will notice that this vertical line does not overlap with this vertical line, which enables the authors to say there is a statistically significant difference in the performance of this memory test based upon which correlated with the severity of dental fluorosis. Grangene said about this, fluoride seems to fit in with lead, mercury, and other poisons that cause chemical brain drain. I want to just quickly end with this, just to put this into perspective, why this is significant, why he's concerned. He's just written a book, it's called Only One Chance. In other words, if you disturb a child's mental development at a very early age, or even at the womb, it has lifelong consequences. But here is the normal distribution of IQ. It's a typical normal distribution of any human trait. This means that the average person has an average value, but we've got people out here that would have very high values, people out here would have very low values. Let's just color it in. The green area represents the fraction of children out of the total that have an IQ above 130. It means they're geniuses or very, very bright. And the mauve area are children, that area under the curve is the fraction of children who have an IQ less than 70, they're mentally handicapped. Just finishing in just 30 seconds. Now, if you shifted the whole curve over by 5 IQ points, here's the problem. An average person would not notice this. A parent would not notice the difference of IQ between intelligence between a child, one sibling at 100 and one sibling at 95. So for the average, if you're looking at the average, there doesn't seem to be much of a problem here. But look at the two tails. If you did that shift, and we think we did this when we had lead in gasoline, you'd shift over by 5 IQ points, then it means that you would halve the number of geniuses in your society and double the number of mentally handicapped. And remember that the average drop in those Chinese Indian studies was, an average drop was 7 IQ points. I'm not sure if this warrants talking. I just mentioned it briefly. I don't think it's particularly scientific, but it's interesting that, like many things, it's going in the right direction, or if you like, the wrong direction. Because this represents, this curved line here, is the percentage of the state population in the United States that is fluoridated. So more fluoridation as you go to the right. And this is the children who are mentally handicapped, the percentage of kids that are mentally handicapped. So how significant this is, because there's many factors that could be involved in this, but it's interesting that we are seeing an increased number of mentally handicapped as a function of the percentage of the state fluoridated, and that's where, and that is, I wouldn't offer that at a scientific conference, but I just want to show you that just for interest. Thank you.
Okay. Well, hang on, Bill, before we move on to yours, are there any questions? Just a moment.
Okay, I think this is working.
Sorry, this is just to understand something that you said. When you had the graph up of the single village and the differences in fluoride that the kids got in the different numbers at the different levels, so how did you work out, I might have missed it, how did you work out that, you know, I think there was 8 kids had whatever parts per million of fluoride and 250 had limited, you know, fluoride in there, or have I missed the point of the graph?
No, what he did, I'm not quite sure of your question, but what they did was they, in each case, they measured the fluoride in the well water. Okay. So for each child, there is a number of the level of fluoride in the well water, so they simply gathered together the kids in that range.
Okay, multiple wells.
Yeah, multiple wells. Yeah, yes, thank you. Thank you, I should have made that clear. Good.
Okay, there's another question here.
Thanks. I know a lot of your, all your studies work on children. As a matter of interest, and I know that there's obvious difficulties in doing so, but are there any adult studies on IQ differences with fluoride? There's obviously differences because of the development of kids, etc.
No, I'm not aware of, hold on, there are some behavioral studies with adults in industry who are exposed to high levels of fluoride. There are a battery of behavioral tests, so that has been done. But what we have got, of course, for other issues, you have got other issues, like take PCBs. When they found a drop in IQ with PCBs, they find this is persistent through life. So if you pick it up early, you can be pretty confident that it's going to have a lifelong impact on the adult and so on. But I'm not aware of any studies that have been done on IQ in adults.
We've got another question back here.
Thank you.
At home, how can we test for fluoride at home or at home? Is it an easy test?
I didn't understand that.
For testing fluoride at home, is there an easy test for finding how much water we've got, fluoride in our house water?
Is there a way of removing it, or?
Well, I think the answer to that would be that Sydney water, so if you're in Sydney...
Testing the level, is there a way to test them?
Yes, you can get home testing kits for fluoride levels. Yes, you can. You can get colorimetric tests, and if you've got some scientific background, there are ion selective electrodes for fluoride, which will probably cost you about a couple $100. And you have to be careful with the buffering. There's a particular buffering system that you have to use. So it's not straightforward. You just can't buy the machine and plug it in. Whereas the colorimetric test, the color test, is something that anybody could do with just read the instructions.
Okay. So with the statistics on the 2015 study, I think it can still be statistically significant even if the error bars are overlapping there.
Again, I couldn't understand. Say it again slowly,
So
closer to the microphone.
So the graph you showed with the 2015 study, and you said that it had overlapping error bars.
Yeah.
So I think it still looks like it's probably still statistically significant there.
Yeah, this is very, very important. Statistics are important. It's a good discipline to apply to any study like this, any epidemiological study. But it doesn't mean that the results are not real. Just because the results are statistically not significant by a certain test does not mean the results are not real. In this particular case, it was a preliminary study. They only had 50 children in the study, which makes it difficult with that small number to get statistical significance. What I find interesting is the trend. The trends are going in the, if you like, the right or the wrong direction, however you want to see it. The trend. So this would be a classic case where people would look at this study and say, your results are important enough to go back and do a larger study with a larger population, which is what they're going to do.
I was just saying, I think it's better than you're saying with the statistics there, because you can have error bars which are overlapping, but still have the difference of the 2 points being statistically significant.
Yeah. Okay. Well, I got to tell you, statistics is not my strong card, and I have to rely on other people, particularly Chris Neurath, to take me through every study and explain to me whether it's a strong study or a weak study. And he does that very patiently.
Okay, we've got another question here.
Hi, I actually don't have a question, but it's some information. You asked what we can do at home. I'm actually getting my water tested for fluoride next week. It's costing me $22. So just go to a reputable pool shop and they will put you on to the appropriate people.
Reputable pool shop. Okay, cool.
Now,
We've got time for one more.
yeah, I've got a serious question. We seem to have lost 2 of our panel members. Is that true?
No. Bruce has left, but Charles...
Oh, yes, good.
Pandera
Good,
here.
good.
And if they want to add any or make any comments, I'll happily take that.
My question is not directly related to IQ, but are there any medical tests to measure skeletal fluorosis?
Ron, could you repeat that? I couldn't hear.
Medical test to measure skeletal fluorosis? Skeletal
Oh,
fluorosis?
yeah. You can. Well, what you can do is to measure the level of fluoride in the bone. That's what we should be doing with the large population. We're not doing it in any fluoridated country. But what they do in India is they ask the villager to put their hands, join their hands behind their neck. And if someone has got the early stages of skeletal fluorosis, because the first thing that it impacts is the connective tissue, makes it stiffer, then they can't join their hands there. Nor can they touch their chin to their chest. So they get that early, very simple and cheap test. Another one, an X-ray, the bones which give it the first indication of the 2 bones in the forearm here. You can see the thickening of the bones in this forearm with X-rays. And the world's expert on this is Dr. A.K. Sushila in India, who's literally looked at thousands and thousands of skeletal fluorosis victims in India.
Is it Jiang study? It's
Yes.
a very interesting study, but I'm sure you'll agree with me that, that the results could be as a result of many things, not just the fluoride that you pointed out.
Yes.
So many different factors, and you agree
Well,
with that.
it's true of any study, but he did try to control for a lot of the obvious ones.
And you've numbered a lot of studies that show that there are effects of fluoride in various neurotoxic studies and many other studies. Did you number how many studies showed no result?
Yeah, I do. Out of the IQ studies, there have been 7 that didn't find a statistically significant difference. 7 out of 50. So 43 yes, 7 no. And the 7 no includes the study done in New Zealand. Of the animal learning memory, 30 found impact on learning, 2 did not.
You'd agree, though, it's harder to publish a negative than it is to publish. It's harder to publish a negative result than it is to publish a positive result. You'd agree that too, wouldn't you?
Yeah, and of course you can't publish a study if it's not done, which is what's happened in Australia, New Zealand, Ireland, England, Canada. They're simply not doing any of these studies. And this event, this study done in New Zealand, is very rare indeed.
Pri, did you want to make any comment?
Having lost one panel member, I just want to make an appeal to the audience to remain engaged, ask questions, because this is exactly what we need in the current the scientific climate. You know, as an environmental health researcher, I know that we are exposed to thousands of chemicals, and it's very hard to often differentiate what causes what. But the correct way is to engage these presenters and to increase our knowledge. So please be tuned.
Great, thank you. Okay, well, thanks, Paul. Now just a short break.